The last part of our discussion in Lesson 3.4 focuses on relative change and elasticity. Let's start with a definition for relative rate of change. The relative rate of change is the rate of change of the amount of the quantity divided by the original amount of the quantity. In the language of derivatives, you can see that expression for relative rate of change can be written as f prime of x over f of x, or as a percentage, 100 times f prime of x over f of x. Now let's focus on elasticity of demand. So you got to remember that the demand equation that we've been working with has the form P equals f of x. With a little bit of algebra, the equation P equals f of x can be solved for x so that it has the form x equals f of p. Then, if we were to compare the percentage relative rate of change of f of p to the percentage relative change rate of change of p, we get this pretty complicated fraction, 100 times f prime of p over f of p divided by 100 over p. And when you simplify that expression, you get p times f prime of p over f of p. And that expression has a special name. In fact, economists call the negative, or the opposite, of that quantity we calculated the elasticity of demand. We'll refer to the elasticity as E of P, which has this formula: negative P times f prime of P over f of P. So what does this mean? Well, this is a way to characterize the demand. The demand is said to be elastic if the quantity E of P turns out to be greater than 1. The demand is unitary if E of P is equal to 1. And the demand is inelastic if E of P is less than 1. So you're probably thinking, what does this really mean? I get it. Elasticity really tells us the behavior of the revenue as we change the unit price. So for example, if the demand is elastic, in other words, E of P is greater than 1, then an increase in the unit price will cause revenue to decrease. If we increase the price, our revenue will go down because demand is elastic. If we decrease the unit price, this will cause the revenue to increase. Again, we're still working with E of P greater than 1. For a demand that's inelastic, a decrease in the unit price will cause the revenue to decrease. And an increase in the unit price will cause the revenue to increase. Finally, if the demand is unitary, with E of P equal to 1, an increase in the unit price will cause revenue to stay about the same. So we've talked about the relationship between the elasticity and the value of 1, but let's also talk about the actual value of E of P itself. When the derivative of f of p is positive, a 1% increase in unit price results in an E of P increase in quantity demanded. And when the derivative of f of p is negative, a 1% decrease in the unit price results in an E% decrease in the quantity demanded. In other words, this elasticity value will determine the percentage of either the increase or a decrease in the quantity demanded. So I just threw a lot at you. It might help to see an example and put this stuff in context. So example 6, which of course this is part of the video series we've been doing on marginal analysis. We're asked to consider the demand equation P equals negative 0.02x plus 400. And our domain for x is 0 to 20,000. And this equation describes the relationship between the unit price in dollars and the quantity demanded of the Arcosonic Model F loudspeaker system. We've moved into loudspeakers now. We're not dealing with widgets anymore. Our job in this example is to find the elasticity of demand, E of P, to compute the elasticity for a production level of, or for a price of $100, and compute the elasticity for a price of $300, and then interpret the results. And that's what we're going to do. So when you start one of these problems, the first thing you want to do is solve for x. This will give us our f of p. And so that's what I'm going to do with this equation here. I'm going to subtract 400 from both sides. So you get negative 0.02x equals p minus 400. And when you divide both sides by negative 0.02 and simplify, you get f of p, x equals f of p, which is 20,000 minus 50p. And that 20,000 is negative 400 divided by negative 0.02. And of course, p divided by negative 0.02 is a negative 50p. So this is my f of p. And then we can find f prime of p because we'll need that as well. That's just negative 50. Okay. For part A, we're supposed to find E of P. And so what we do for E of P is we do P, the opposite of, we do the opposite of P times f prime of P, which for us is negative 50, divided by f of P, which is 20,000 minus 50p. And with a little bit of factoring, I can factor negative 50 out of the bottom. And also you'll notice that, let's go ahead and write that out. So this, on the top here, we get 50p. The negatives, negative 50 times this negative sign out front make a positive 50p. And on the bottom I can factor out a 50. And this would be 400 minus p. And so by canceling these 50s here, we get the E of P is P over 400 minus P. This is our elasticity equation, E of P. And so for parts B and C, we're just supposed to plug some values into our E function. The first one, we're still supposed to calculate, oh goodness, my pencil's not working here, E of 100. So let's do this again. So this is E of 100, which for us would be 100 over 400 minus 100, which is 100 over 300, which is 1/3. And we're supposed to interpret that result. What does an elasticity of 1/3 mean? Well, 1/3 is less than 1, right? And so that means this is inelastic. And that tells us that a 1% increase in price will cause approximately a 0.33% decrease in quantity demanded, right? Because our derivative was negative 50. So I'm gonna just note that here. If the price goes up 1%, if we increase the price by 1%, we'll get approximately a third of a percent, or 0.33% decrease in quantity. Demanded. Now let's calculate E of 100, the elasticity, 300, at a price 300. Well, when you plug that in, you get 300 over 400 minus 300. Remember, these two equations are based on our calculations on the last slide. We had E of P equals P over 400 minus P. And this value works out to be 3. It's 300 over 100, which is 3. So that's the elasticity at a price of 300. And as you know, this is greater than 1. So the demand is elastic at P equals 300. Demand is elastic at P equals $300. Here, if we increase the price by 1%, we'll see a drop in the quantity demanded of about 3%. A 1% increase will result in about a 3% decrease. 1% increase in price will result in about a 3% decrease in quantity demanded. Oh, this handwriting's horrible. I'm going to write it in notation. If you increase the price by about 1%, you're going to decrease the quantity demanded by about 3%. That's how you'd interpret that elasticity. Just a note to clear up my findings on the last slide. Because our derivative f prime of p was negative 150 in this example, an increase in unit price will result in a decrease in quantity demanded. If you want to verify this, just try plugging in some values for p. Try $100 and then $102 and notice the change in the corresponding values of x. That'll do it for our discussion on elasticity. Good luck.